Hello everyone, my name is Ibukun Aleshoe, and today we'll be talking about an algorithm, one of the more popular algorithms in data structure and algorithms. And we'll be talking about the bubble sort. And this algorithm is one of the more popular algorithms that exist in programming. And we'll be using this algorithm to solve a problem. Would also be solving the same problem using another method, basically trying to find out if the bubble sort is the best algorithm for solving our problem. So the problem we'll be solving using this algorithm is the moving zeros to the end problem on Code Wars. And basically we'll be trying to find a solution to this problem. Okay, so let's get started. Let's start by first of all trying to understand what bubble sort is. So bubble sort is a simple comparison-based sorting algorithm. The algorithm works by repeatedly swapping adjacent elements that are out of order. The algorithm gets its name from the way smaller elements bubble to the top of the list with each iteration. The basic algorithm works as follows. Basically, it takes two elements of the first array and compares them. Now, if the first element is greater than the second element, bubble sort will swap them. The algorithm will swap them. Then after swapping them, it will compare the second and the third element of the array. And if necessary, it will also swap them. Now, it will continue this process through the entire array, comparing and swapping adjacent elements as necessary. And it will repeat the entire process for as many times as necessary until the array is sorted. So let's see a visual representation of this algorithm. So this is a website or a web app that allows you visualize algorithms. And we're just going to simply visualize the bubble sort algorithm. On the screen here, we have an array of numbers: A, 29, 10, 14, 37, and also 14. So basically, I'm just going to add a few more just to make it a little bit, just add more elements to it. I'm just going to say 78. I'm going to say 78 and 4 to 16 and let me say 52. Okay, so we have an array of numbers: 29, 10, 14, 37, 14, 78, 4, 2, 16, and 52. So I'm going to start sorting this array. So I'm just going to click the go to update my array. Oh, sorry, so you're restricted between 1 and 50 inclusive. Okay, so I need to make changes to my array here. So I'm just going to use the maximum 50 here. I'm just going to click go to sort of input my array. Yeah, so now I have my array imputed on the screen. So I'm just going to start it. And I'm just going to say sort. So it will go through the array. Can you see that it compares the elements? It compares the elements closest to the one element, the first element. It compares the first element to the second element. And if the first element is larger, is greater than the second element, it sort of swaps this first element with the second element. So what this does is that it moves the larger value to the right hand side each time it iterates over the element. So at the end of the entire process, at the end of the algorithm, the entire array should be sorted. Okay. So let's just wait it through, and our algorithm should be just about done. Okay. So this is the visualization of the bubble sort algorithm. And basically this is it. And this is what happens while it swaps. It says do swaps equals to false for I equals to index of the last sorted minus 1. If the left element is greater than the right element, you swap the left element and the right element, and it should increase the swap counter. And this while loop simply means it should restart the entire process. Okay, so let us move further in this process. So the next thing we want to do is look at our problem, and our problem simply says moving zeros to the end. Basically, we'll be given an array of numbers, say an array, say false 1 0 1 2 0 1 3, and probably the string a. So basically what we want it to return is the same array with all the zeros that appear in the array to the end of the array. So this is where we're going to be working. This is going to be where we're going to solve the problem. So the first thing we need to know about solving this problem is we need to write a procedure that actually helps us solve the array. And what we're going to do is we're going to take a list of sorted items, and we're going to take the list of sorted items. We're going to find the length of the item, then we're going to loop through the item. The reason we're looping twice, so we're going to loop through the items, and if the item on the left is greater than the item on the right, what we want to do is we want to swap them and basically repeat the entire process till our entire array is sorted. Let's get started. So the first step we're going to use to solve this problem is the bubble sort. And we're going to try and solve this problem in two ways, just so that we can get a better perspective of whether bubble sort is the best method to actually solve this problem. Okay, so the first thing we want to do is define an empty array to store our non-zeros, to store all the non-zeros in our function, in our array. So we're going to say let the non-zeros be equal to an empty array. Okay, so after defining an empty array, we're going to define an iterator in order to help us iterate over our array. Let non-zeros be equal to 0. Okay, so then the next thing we're going to do is actually write the for loop that actually helps us iterate over our array. And we're going to say for let I be equal to 0, where I is our iterator, where I is less than the array dot length. What do we want to do? We want to increment I by 1. And basically we've just written our for loop. Now let us first of all check if our array, we're going to write a conditional that checks if the current element of our array is not equal to 0. And basically what we're going to do after doing that is, if the element is not equal to 0, we're going to push that element into our empty into a non-zeros array that we defined here. So we're going to say if the array, the current element of the array being iterated over is not equal to what? To 0. We want it to append, or rather push. Push is for JavaScript, to push the current value to the array non-zero. Okay. So the next thing we want to do is actually write a function, or rather a statement, an else statement that actually increments our non-zero whenever this doesn't happen. So we're going to say else num zeros plus plus. Okay. So now that we've actually gone through the process of actually checking that our array, then writing the conditions that actually takes in our array, and writing a for loop actually that takes in an array and pushes all the non-zeros into this empty array that we defined here. Okay, so the next step is to actually use this num0. Remember that this num0 is what counts the number of zeros that whenever we don't push a number that is not 0, we incremented our num0 counter. So what we want to do is actually write a condition that checks and pushes 0 into our array, into our actual array, that pushes the zeros into our actual array and allows us to print out, that pushes 0 into our actual array. So what we'll do is we'll write another for loop that takes care of this for us. So outside of this, we're going to say let I be equal to 0, and where I is less than the number of zeros that we've actually encountered, want to say I plus plus to increment I. So the next thing is we want to push the number zeros. We want to push 0 into our array. Okay. So the last thing we're going to do is actually return the array non-zeros. That's the last thing we're going to do. So I'm going to so let me just explain what this function does. So this function takes in an array, and what it does after taking in the array is actually it returns the modified array with all zeros moved to the end. Now, if the array it first creates an empty array called non-zeros to hold the non-zeros right here that we defined here. And the next thing is it loops through each element of the array. And after looping through each element of the array, what it does is if it finds a number that is not 0, it actually pushes that element or that number into the array non-zeros. Then if it doesn't find an element that is not equal to 0, what it does is increase the count of our non-zero counter here that we've declared. So after doing all of that, the next thing it actually does is we define a for loop that actually counts the length of our non-zero, where it says let I be equals to 0, where the value of I is less than the number of the value of our non-zero. Yeah. our number zeros, that is after this for loop, right? What we want to do is say non-zeros and actually push 0 into our non-zeros for each time this loop runs. Then lastly, what we're going to do is just return the value, non-zero. Okay, so first of all, we need to talk about how this actually implements bubble sort. Now, the bubble sort works in this array, in this particular problem, this particular algorithm that we've written, by simply comparing the item, comparing the adjacent value, and simply swapping them. It takes in it compares the value to what? To 0, and simply pushing that value into our array, non-zero. And it repeats the process until each element of our array has been compared and each element of our array has been sorted. So what we actually want to do is find out how fast this algorithm runs. So what we're going to do is just test the algorithm now. We're just going to go ahead and just click test. And I'm just going to test it to see if it actually works. Okay, it says num0 not defined at move 0 line 7. Okay, 10 line 7. So let me just fix that error quickly. Okay, so the error was because my Z was in small letter and not uppercase, was in lowercase and not uppercase. So let me test my algorithm again. And yes, so this algorithm that we've written actually runs in 882 ms. So I'm just going to write that down somewhere on the screen just for for safekeeping. 882 for my first algorithm. Okay, so I'm going to implement a second solution to this problem, and we're going to try and compare both algorithms to see which is actually faster. Now, there's one thing I should mention, that the big O of this algorithm is actually omega. Oh, this is too big. I'm just going to put it a little bit, make it a little bit smaller. It's actually the omega of n. Now, this is because we are iterating through the array only once to move the zeros to the end while keeping the order of the element of the other element of the other elements of the array. Now, the other operation we perform, such as swapping the two elements, are time constant and do not affect the overall complexity of this algorithm. Okay, welcome back. And we're going to implement a second solution to our problem. And what we're doing, the second solution we're going to implement is going to make use of a method that actually iterates over the array using a loop. Okay, so let's get started. I'm going to do something now and just copy my current solution somewhere and sort of just remove it so that I can start writing the solution to the second problem. Okay, so the first thing we want to do is actually define an array that actually stores the number of zeros in our array. So what we'll do is we'll say let 0 array be equal to an empty array. Okay, so after that, we're going to define a for loop. We're going to define a for loop that actually iterates over the array once So what we're going to do is we're going to say for let index, which is also I. Let me use index. Let I be equal to 0. And after I equal to 0, we want to say the index is less than the array length. The index is less than the array length. What we want to do is increment the index by 1. Okay. Sorry. It's supposed to be index. Increment the index by 1. So the next thing to do is define a conditional that says if the array length, the array index, the array of the current index is equal to 0, what do we want to do? This should be outside. It's equal to 0. Is equal to 0. We want to say 0 array dot push and array index. So the next thing to do is to say array dot splice and pass in index and 1. So after that, what we want to do is the increment index. The increment index. Okay, so the reason we're actually incrementing is to account for the splice that changed the array. Okay, so the final thing we want to do is simply return okay, this is my for loop. Simply say return the array dot concat and 0 array. Okay, so I'm going to run this code now. Okay, so my comment is not written properly, so I'm just going to comment it out. Okay, so I'm going to run this code now, and we are going to actually try to keep track of how long this solution runs for. Just going to simply click test. Okay, so my solution works now, and I'm just going to go ahead and record the time now it took to run. My second algorithm took 890 ms. Okay, so from what we can see of this algorithm, we can see that our first solution actually runs more efficiently and faster than our second algorithm. So I'm just going to bring back my first solution, and we should be done for this recording. Okay, so what do we know from what we've seen so far? We know that my second solution is actually faster and more efficient than my first solution. So bubble sort might be sometimes the best solution, and sometimes it might not be the best solution. But the best you can get out of a bubble sort is actually this O of n This is the best algorithm. This is the best runtime you can actually, time complexity that you can actually get from bubble sort. Now, bubble sort is not especially very useful when you're calculating, when you're trying to solve for big data sets and the rest of it. It's actually best for smaller data sets like our test cases here. Okay. So, thank you for being a part of this session, and I'll see you next time. Bye-bye.